Okay, so I'll review again. Okay, so you can tell by the quizzes that students understood the translations quite well, and I'm sure that when we do the reflections, it'll all come back to you. Okay, so for lesson 3, we're going to start on page 92. I'm just going to fly through these pages. Okay, so we're going to be looking at 3 types of reflections. There's the reflections on the x-axis, reflections on the y-axis, and reflection in the line y equals x. Now y equals x, that's a review on top of review because we did it last year, you did it 3 days ago, and we're doing it again today. Okay, now reflection on the y-axis. Now you can see the before and the after for those people that are having trouble seeing what the after looks like. Okay, it is, right, this one is the before. Actually, why don't I do the after? That would make the most sense. This one is the after, okay? So it was, most of it was above the x-axis, and then it got put below the x-axis, okay? Now, this is a graph of y equals f of x when it is reflected in the x-axis, and then it is a graph of, now what do you do to reflect it on the x-axis? Okay, yes? What are we replacing? What with what? Come on, you guys, you remember this. What are we replacing in y equals f of x? This is what we're dealing with. That's y equals f of x over there. What do we replace to reflect this? We're going to take y and we're going to with negative y. So this is negative y equals f of x. But if I was to get everything as y equals, it would be y equals negative f of x. So remember, do you see how that negative is nowhere part of that x? So even though it's on the other side, it still belongs to the y. Okay, so this is negative f of x. Now, if we take this thing and we reflect it on the y-axis, then it is a graph of what gets replaced. What's the replacement? What's the replacement? X with negative x. So this would be y equals f of negative x. Okay, so that would be over here, y equals f of negative x. Now if we reflect it on the line, now what's that dotted line called? The line of what? Y equals x. Okay, then it is a graph of either, now what's the replacement? X gets replaced with y and y gets replaced with x. So that is a graph of x equals f of y or y equals f of negative 1x. And I guess we can just write that one more time. X equals f of negative 1x or x equals f of y. Okay, so here's kind of the money of this whole unit, okay? So placing x with negative x is reflection on the y-axis. Y with negative y, reflection on the x-axis, and interchanging x and y is reflection on the line y equals x. Okay, next page. Let's just do a couple because it has been a while. So let's take A and do y equals negative f of x. Now what is the replacement on that one? What happened? Because this is the original, y equals f of x. What was the replacement? Yeah, y got replaced with negative y. So what is the transformation? A reflection on x-axis. Yeah. Okay. So all you do is you take every point that's on above the x-axis, make it below. Now, does anybody remember what these are called? Excellent. Okay. So I want you to go all the way back to the title. Okay, I thought, why don't I talk about invariant points when we actually have invariant points? Invariant points are points on a graph which do not move after the transformation. For reflections, it is anything on the mirror. Okay, so if it's on the mirror, it's an invariant point. Now, I said that the diploma loves domain and range. They love invariant points too. Okay, so there'll be a question on, there'll be a domain range guaranteed, domain range and an invariant point question. They love them. Okay, I mean, maybe this is the first time they'll never do it, but I doubt it. Okay, so those are all invariant points. Why? Because they're on the mirror. So they're not moving. Remember, invariant points mean don't move. So everything else is going to move. So like 4 or negative 4, 6 is going to become negative 4, negative 6. Good. So just reflect each point. Okay, hopefully you get something that looks sort of like this, which again illustrates those invariant points. When you are invariant, that means you are unable to change. Okay, and those points are very invariant. Okay, next one. Let's move right. Y equals f of negative x. What was the replacement? What got replaced? X with negative x. That is a reflection on y-axis, right? Okay. What is the invariant point? There's only one this time. 0, 4 is the invariant point, okay? Now you're going to take every every x, because it's a reflection on the y-axis, so every x. Okay, so x got replaced with negative x, right? I put negative y up there for some weird reason. Okay, so if you look at like negative 2, 6, that becomes 2, 6. Okay, so just reflect each point, and they're pretty good at showing you the points there. So you don't have to try and actually guess and read them. So it should look like that. And again, make sure that I am crossing at that 0, 4. Okay, now what is the invariant point for x equals f of y? Now, the replacement for this one is x goes to y and y goes to x. What's the invariant point? 2, 2. Okay, it's the only one that will not change. Okay, so this one is doing a, yeah, it's an inverse, exactly. And it is doing a reflection on the line y equals x. So all you're doing is reversing every single point. Now these ones are, people lose their bearings on these ones, right? So do each point, then connect the points, okay? And you'll even see as you're going through this, you'll be doing halfway through and you're going, I don't know if I'm even doing this one right, okay? Finish it up, connect the points, look at it for a couple seconds and go, oh, yeah, that is right, okay? Because like you look at negative 5, 0, right? It comes down to 0, negative 5. So it's down there, right? And then I'm going to just go left to right, I guess. Negative 4, 6 will be 6. Negative 4. So it's right there. Okay. And I can even join those now. I know those two join. And then negative 2, 6 is 6. Negative 2. So it's right there. Okay. And then I could even so I got, let's just 0, 4, 0. That's going to become 0, 4. Okay, that one's going up there. I'm going to come all the way down here. 7, negative 3 becomes negative 3, 7. It's right here. And then I got 10, 0 becomes 0, 10. So that's up there. Okay, so then you look at it and you go, oh yeah, okay, that is a reflection. Okay. Now, this one here, the original is the thin line, the thick line is the after. What was the replacement? Okay, let's get through these quick, guys. Yell it out. What's the replacement on that one? Yeah, x to y and y to x. So that would be, the equation would be y f of negative 1 x. Okay, B is a reflection on which axis, x or y? On the y. Okay, so that means x got replaced with negative x. So that is y equals f of negative x. Okay, next one, reflection on the y or the x? On the x. So y goes to negative y, which is y equals negative f of x. Okay, now these next two pages, so we'll go to page 95, they're basically trying to say the same thing when doing reflections. Order does not matter. Okay, so, what does that mean? Okay, so if you had y equals negative f of negative x. Now, do you see how we have a reflection on the y-axis and a reflection on the x-axis? So you could do the reflection on the y, then the reflection on the x. Or, if you wanted to, you could start with reflection on the x, reflection on the y. Okay? So, you'll get the same answer. Okay, so let's just do a couple of these so you can see that. So, let's do this one here. So I have a reflection in the y-axis. So if I was to take this, reflect on the y-axis. Now, first of all, I'm dealing with y equals f of x. That's my original. Okay. So if I started with y equals f of x, a reflection on the x-axis, would this be a replacement for the x or the y? The x. So x goes to negative x. So I'm doing y equals f of negative x. So let's reflect it on the y, and oops, it will be right here. Okay. Now the next thing says do a reflection, and this is interesting actually, because some people might not see this, but do a reflection in y equals x. So I'm going to take x go to y and y go to x. Now the question would be, what would the new equation look like? Very good. X equals f of negative y. What do you think is a common mistake there? Or none of you would have made a mistake there. What do you think I commonly see? No. I get negative x equals f of y. People just trade those two, okay? The negative stays put. So now we're going to take this and we're going to reflect it on this line right here, right? In other words, we're going to reverse the points. So, but this is actually number 1. Put a 1 here because that's what we did, number 1 right there, right? What's that top point? That top point is negative 2, 6. That's beginning to come 6, negative 2. That'll be the peak. Okay, and then I got a negative 1, 3, becomes 3, negative 1, and then the other one's here. So that's what that'll look like when we're done. Okay, so I just wanted to do one together just so we can see. Let's do this one here, because that says with y equals f of x, do a reflection in y equals x, and then do the reflection in the x-axis. So it's basically opposite order of the one before. So then I will get x goes to y, y goes to x. That is x equals f of y. Okay, now remember, here's my reflection line. So this is invariant. Okay, you can see this goes to here, and this down here. Okay, that's the reflection. Again, you just reverse the points. And then a reflection in the x-axis. Well, that's y goes to y. Oops, sorry. Y goes to negative y. So x equals f of negative y. Okay, and that would become right down here. Okay, so why is this different? This negative up here changes things. So I guess the above, when doing reflections, those two are the same. Okay, but always be careful when x goes to y and y goes to x. Okay, some order does matter, okay? So be careful. So in other words, if we would have done these two, where you got a reflection in the y equals x and a reflection in the y-axis, you get this first. So what are you? Yeah, too big here. And then it comes over here. So it comes over here. So when doing reflections, order does not matter if you're just doing x to negative x and y to negative y. But be careful, if you do a y equals x in there anywhere and x equals y, it does change the order. Okay? So let's actually fill this in. X goes to y, y goes to x. So x equals f of y. Now, if I want to do x goes to negative x, then I have negative x equals f of y, or x equals negative f of y. And you see how they are different when okay, so these two are actually equivalent. And that's a good diploma question too, right? A reflection in the y-axis followed by a reflection y equals x is equivalent to. Now don't get caught up with saying, you know, just the opposite. Because as you see, just the opposite gives a different picture. So the correct answer would be a reflection y equals x followed by a reflection in the x-axis. Okay, does that make sense? Okay. If you ever get a question like this on the diploma, is what equals what, take a couple seconds to do something kind of weird, do your own little graph, see what happens, instead of just answering that right away. Okay, so for this one, we're doing 1 to 9, A and C, and 10 to 14. Okay, next one. Okay, so this is just reflections part 2. Now all of this is all review, but I just want to do a couple quick ones here. Now we're going to deal with, let's actually change the equation. So how would you do y equals 10 to the x? I want that to be a reflection in the y-axis. Now, what have we always known to be a reflection in the y-axis? What's the replacement? X with negative x. So this would actually be y equals 10 to the negative x. See, the rules don't change. It's a great thing about math. They stay the same all the time. Okay? That's what always drove me nuts about chem. Okay? Oxygen will combine with helium, except when, and there's like 800 rules when it doesn't. I'm like, well, why is it even a rule then? Okay? Fails most of the time. Okay? Yeah. And you really notice that when you're teaching your children English, they're like, Dad, I read that yesterday. No, actually, we say we read that. He's like, huh? Why don't we say read it? I don't know. We just don't. Okay, we say read. Yeah. If you ever have to teach English, you will find out that it is a weird language. Breaks a lot of rules. Now, let's look at this one here. This is a great question. So, your original, your before and your after. What happened? How did you get from y equals x cubed to y equals negative x cubed? Yep. Who does that negative belong to, the x or the y? The y, right? Right? Isn't this the same thing as negative y equals x cubed? So that means y got replaced with negative y. So this would be a describe, needs words. This is a reflection in the x-axis. Oh. I know what you're asking. Reflection in the x-axis, right? Now, this one has an or to it. Now, if you had y equals I just want to talk about this. Negative 2 squared. What's the answer to that? Try it in your calculator. Yeah, without brackets. What is this? Negative 4. What is this? Okay, do you see the difference? Okay. Is that negative being cubed? No. Okay. I just want you to try this in your calculator. What is negative 2 cubed? Negative 8. What is negative 2 cubed? Negative 8. So, the or for that one, it could have been y equals negative x cubed at one time, right? Which is the same thing as negative x cubed, right? So this could be an x replaced with negative x. Therefore, it could also be a reflection on the x-axis. Cubes, fifths, right? Anything that has a even exponent changes the value if it's in brackets or not in brackets. Now, why don't we actually try and say, like, what? Why does this work? Like, how can you do a reflection in x and reflection in y, and it still gives the same picture? Okay, so maybe I'll answer your question, why this, and then I'll get to you after if I don't. Okay, so I want everybody to put y equals x cubed into their okay, I'll hit graph. Now, if you reflected this on the y-axis, it would look like this, right? If I reflected on the y. What happens if I reflected on the x-axis? It would look like, see how they both give the same graph no matter what? Okay? So sometimes when you reflect something on the x or the y, it does give the same picture. Okay? Now, here's another one that I want you to look at this. Tell me which reflection would give that exact same graph. Which reflection? A reflection on the y-axis. Okay, let's talk about that. A reflection on the, so this is a y equals x squared graph, correct? We said a reflection on the y-axis would produce the same graph. So reflection on the y-axis, what gets replaced? X with negative x. So that would be y equals negative x squared. What is negative x squared? X squared. So y equals x squared equals y equals x squared. It's not too far of a jump to say it should produce the same graph, right? What's your question?
On the or part, would that be, you said it's a reflection on the x-axis again.
Oh, yeah, that's y-axis. Okay, so those are important anomalies because the diploma has, like I said, they have questions on there that have to separate the 80s from the 100s. They don't want anyone getting 100 in the diploma that doesn't know their stuff. Okay, that diploma is supposed to get a 65 average, right? That's what it's designed for. And you're like, how do you know that? Because they field test them like crazy and they know their questions, and they make sure that there's that many of these, that many of these, that many of these, it gets a 65. Okay? So how are they supposed to separate people? They put these kind of questions in there, right? So I'm going to try to go through as many of these weird anomalies as possible. So you actually start thinking better that way, and therefore are able to catch these kind of things. Okay, the next, let's just do A. What do you think happened here? Y equals x squared. What would be the formula for that thick graph? What got replaced? So the x got switched with y, and y switched to x. So that would be x equals y squared. Now, I have to take the square root of both sides, correct? Because I'm taking the square root, put plus or minus. So plus or minus square root x equals y. Is that a function? Not a function. Okay. Let's just get through this quick. Now, here is the equation I'm going to be working with. Here is the graph that it gives. Okay, so it said, what would be the equation for y equals negative f of x? Negative f of x. Who does that negative belong to? Y. So this is y got replaced with negative y. So that is negative y equals 6 over x squared plus 3. But we wanted to get it to y equals, so we're going to put y equals negative 6 over x squared plus 3. Now, can you guess what that graph would look like? Hopefully you're thinking it would look like this. Oops. Because that is a reflection on the x-axis, right? Okay, y equals f of negative x. So if I do f of negative x, that means I'm putting a negative x into the equation. So y equals 6 over negative x squared plus 3. Yep. No, you just take the x and replace it with negative x. You got to be very disciplined with that. So no, because the plus 3 is already in the graph, right? If we added another plus 3, then we would shift it, okay? It's already been shifted when they made the question. This is y equals 6 over x squared plus 3. Now, if you take x and replace it with negative x, what transformation is that? If you take x and replace it with negative x, what transformation happens? A reflection on the y-axis. If I'd reflected this on the y-axis, what happens? Same graph, and it makes sense because they got the same equation. Hopefully you picked up on that these are the same. So it kind of makes sense, gives the same graph. Okay, last one, x equals f of y. So all we're going to do is take x, replace it with y. So let's do that. X equals 6 over y squared plus 3. Now, whenever you're in ratio to each other, meaning one fraction equal one fraction, they're nice to deal with because you can just trade places with those two. You could just bring one up. Doesn't matter, okay? It's like no matter what you do, it won't be wrong as long as you go diagonally and you're multiplying. So this will be y squared plus 3 over 1 equals 6 over x. Okay, now, and actually maybe I can even say I multiplied the 1 up to the 6, so it's gone now. But it's actually there anyway because it's always over 1. And then now it's going to be y squared equals 6 over x, and I'm going to subtract 3 to that. Now, just to finish things off, I'm going to take the square root of both sides. I'm going to take the square root of that side. I will have a plus or a minus on the other side. Okay, and that gives this graph right here. Not happy with that. Yes, did I do something wrong again? The third one? Well, here's the original up here, right? And if this is a reflection on the x-axis, I'm just going to reflect it right here. The third one, you basically have to take this point, which is 2, 0, and make it 0, 2. Take this point, right? So that's how I did. Like, I didn't show that because I did it quick. But the other thing, too, is you can just put this in your graphing calculator, and you'd get it, too. Okay, it's all good? Okay, so we're doing 1 to 9. Okay, it doesn't look like a lot of time, but this is more time than the other class got, and I'd say 80% of the class finished their homework. So.